So today we're going to talk about proving triangles congruent. And in our previous notes, what we had to do is we had to show that all sides were congruent and all angles are congruent. But there actually are shortcuts within proving triangles congruent. And the first one says SSS. It stands for side, side, side. And then the second one, SAS, stands for side, angle, side. And so in the previous section, we learned that the order for triangles to be congruent, all corresponding angles and angles need to be congruent, all 6 parts. But again, we're going to talk about some shortcuts today. And when we do that, we only have to really show that 3 parts are congruent. If 3 specific parts are congruent, then the other 3 parts it will be implied that they are also congruent as well. But we have to look at a little bit of vocab before we get into the actual issue of this. And the first one is included angle. And it's the angle formed by 2 sides of a triangle. So if we look at this picture over here to the right, it says for side PR and side PT, well, the included angle is this angle right here, which is angle P. So that forms the angle, and highlighters might be helpful. Colored pencils might be helpful just to mark things up, because marking the triangles up is really important. So there's the included angle. And side, 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 SSS, says that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. And sorry for the small blank. If you prefer, if you like to abbreviate, you can use the symbol for congruency. They're your notes. Side, side, side. 3 sides. Side, angle, side. SAS says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Again, if you prefer, there's our abbreviation for congruency. So let's practice for a few minutes on determining, and we started this process yesterday. But if we look at the far left at example A, determine which postulate. So we're deciding if it's side, 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 or side, angle, side, if any. So it could be neither as well. Determine which postulate, if any, can be used to prove that triangles are congruent. Well, to the left here, I'll mark up this triangle a little bit. But we've got side, and then we've got another side and an included angle. In comparison, we have a side and another side and an included angle. So what we're looking for, we're either looking for 3 sides that are congruent, or we're looking for 2 sides and the included angle. And again, what we have side, angle, side. We have side, angle, side. We have 2 sides and an included angle. So this is going to be congruent based on the fact of side, angle, side. The important part is the included angle, because if you look at the middle example, letter B, what we have over here on the left of B is we have 3. We've got a side, we've got an angle, we've got a side. We've got 2 sides and an included angle on this triangle, and we still have 2 sides, but we don't have an included angle on letter B. So this one's going to be neither. It's not side, side, side. It's not side, angle, side. You have to follow the same pattern And again, the reason is the included angle was not on that second one. What I wrote down on my notes is I said, well, this one is side angle side, but this one is side side angle, is the pattern that we have on the triangles. Third one. First of all, this type of picture where we have two triangles, it's called a shared side picture, or shared side triangles, because in this particular problem, this length here, if I can get that colored in, so to speak, is in both triangles. It's in this triangle, but it's also in this triangle. So there's the shared side. What we know so far in this particular picture is we know a side with one tick mark. We know a side with two tick marks in kind of the top triangle. We know a side and another side in the bottom triangle. But once again, what we were just talking about is that this length here is the shared side. It is in both of those triangles. So when we mark this picture up, what we can say is that because that length is in both triangles, it's shared, that will determine that it's congruent to itself. And then what we have a side with one tick mark, two tick marks, three tick marks is a top triangle. We have one tick mark, two tick marks, three tick marks in the bottom triangle. We have all three sides, so our congruency statement here is going to be side, side, side. Again, asking yourself, do you have two sides in an included angle, or do you have three sides? Again, we're going to see shared side, and when we have a shared side, we're going to have to remember to identify that it's in the same, that side is in the same in both triangles. Get that out eventually. If we look at letter D here, what we have right now is we have two sides. We've got this side, it's congruent to this side. We have this side is congruent to that side. And again, we're trying to determine, do we have side angle side? Do we have side, side, side? Do we have neither? But if you recall from our previous notes, this is called a bow tie picture. If you kind of turn your head to the side, you might see the bow tie. And with regards to the bow tie, we always have vertical angles in a bow tie picture. So once we know that fact, if we can mark up this diagram and label where the vertical angles are, this angle here is congruent to that angle there. Vertical angles, sometimes people think of them as opposite angles. And what we've got the red side, we've got the blue angle, and then we have the black side up there at top. Same thing in the bottom. We have a red side, we've got the blue included angle, and then the black side. So we have side and angle and side. Letter E. We just saw one of these. This is called, again, a shared side diagram. Triangle, really, share side. And it says A is the midpoint of JN. So we've got a little bit of information that we need to help us put some marks here. We want to mark up the diagram. But A is the midpoint of JN, and consequently what that means for us is that JA is congruent to AN. And maybe I should have done it first, but shared side. The shared side is in both. So we've got this triangle here, then we have this triangle here, but in the very middle here is that shared side. It's both pink and blue. And now what we're looking for is, do we have side, side, side? Or do we have side, angle, side? And we don't have any angles marked on this one. So this must be side, side, side. Letter F. RS is a perpendicular bisector of QT. And unfortunately, I've got a little bit more information marked on this triangle than I would have liked on there. But perpendicular bisector, the first word I'm looking at is the word bisector. Remember that bisector means that this length and this length are going to be the same. Bisects, cuts it in half equally. The perpendicular part gives us this angle of RST is a right angle, but angle RSQ is also a right angle, perpendicular. It means that it hits at 90 degrees. And once again, this is a shared side triangle. And our shared side is here. And once we identify that fact that it's a shared side, then we know that the shared side is in both triangles and it's congruent to itself. And then we look. We're looking for, do we have side, side, side? Do we have side, angle, side? Do we have neither? But we've got side, the shared side. We've got the right angle, which is an included angle. And we've got QS, which has one tick mark. Or we've got the shared side, and we've got the right angle, and we have ST. So side length with one. So in terms of identifying whether this is side, 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 or side, angle, side, side, angle, side. Again, what I want to stress is that is the angle included? Because that's important. We need to watch out for included angle. Flipping our paper over, we look at a couple of proofs. Again, on the OST, these are typically worth 2 points. And the thing about these is it's pretty easy to get 1 point on these. If you don't leave it blank, it's pretty easy. And you know, again, as a reminder, that they're going to be probably a drop down or a word bank for these. So start off with what we know. The JA is congruent to ZA, and A is the midpoint of DM. Do the best you can do to fit that in, and that's our given statement. We can also fill in what we're trying to prove, and that's at the bottom here. That triangle JAD is congruent to triangle ZAM, and once we get that filled in, what I might recommend to you is put in a couple of reasons and go back and fill in the rest. Because one of the things here that I see on this problem is that we have the word midpoint in our given. It is a vocab word. So one of the reasons is going to be definition of midpoint. And now we already have half of the proof filled in, and conceivably we could get 1 point on the OST test for having half of that filled in. Other thing to recognize on this particular problem is that this is a bow tie picture, and it almost looks like a bow tie here. Whenever we have a bow tie set of triangles, part of that is that there's vertical angles back in this problem somewhere. And our statement that goes along with vertical angles is that vertical angles are congruent. I'm going to abbreviate. Now we have more than half of the proof filled in, and we absolutely should be able to get 1 point from there. Statement 4, we've got 2 choices. Eventually we're going to have 4, but we have 2 choices today. Statement 4 is either going to be side, 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 or side, angle, side. So we can go back now, and we can fill in 2 and 3, but having the reasons already could be very helpful for us. Definition of midpoint. It says A is the midpoint of JZ. Sorry, A is the midpoint of DM. Get that out eventually. What that means is that this point right here, gotta get that, this point right there, is going to be the middle of that and that. And luckily enough, this problem already is marked up from the perspective of our first part of our given, is that JA is congruent to ZA, so we already have that. So now we can make our statement here is that DA is congruent to MA, and that's based on the fact that we're working with the definition of the midpoint. So right now we've got 2 sides. We've got the blue side and we've got the 2 tick marks that are marked in already. And then we get down to statement 3, and statement 3 says vertical angles are congruent. Well, let's mark up our vertical angles here and here. And when we mark these up, we need to be very careful about naming our angles. So if you start with J, we're going to go J, A, D. We just need to make sure that we go in the same order over there. So JA had the 2 tick marks on it. So we need to start here at ZAM, because ZA had the 2 tick marks on it, and then AM didn't have, oh, it has the blue mark on it. But again, order, very, very important. JAD, ZAM, vertical angles. And now we have our triangle completely marked up. And what we're looking for, we need to decide, is it going to be side, angle, side, or is it going to be side, side, side? Do we have 2 sides in an included angle, or do we have 3 sides? Well, we've got 2 tick marks, green angle, 1 tick mark that's blue. 2 tick marks, 1 green angle, 1 tick mark that's blue. We have an angle, so we're going to finish and say that this is side, angle, side. Last one. Complete the following 2-column proof. This time, we did the bow tie. This one is the shared side. And if you can identify that, that might help us get through something. But shared side is important. On this particular problem, we have a lot of possible statements and possible reasons. And I'm going to try to look at those. I honestly have been remiss in doing that, but I will do better here. But let's start with what we know. Get in there what we know, which is that RQ is congruent to TS, and RQ is parallel to TS. And that's given. Also put in there, what are we trying to prove? We're trying to prove triangle QRS is congruent to triangle STQ. Again, we've got two choices for that answer. It's either going to be side, 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 or it's going to be side, angle, side. Let's mark up this picture with what we know right now. And what we know is that RQ is congruent to TS. We know that part. In this problem, in terms of the given, what it says is RQ is parallel to TS. I wonder if we could make some statement based on that fact. And in fact, I'm also going to mark that. RQ is parallel to TS. And typically what happens when we have parallel lines, and certainly as we look down here below, is when we have parallel lines, we tend to have alternate interior angles are congruent. We're going to put that into here. Alternate interior angles are congruent. And while we're writing that down, why don't we cross off some information so that we don't need that anymore? Here's that. Triangle QRS is congruent to STQ. We can get rid of that. We've got our given, we can get rid of, and now our alternate interior angles, we can get rid of that. So let the box help us here. Again, this triangle is called, or this picture is called a shared side triangles. And our shared side is here. And what we say is, we say that that side is congruent to itself. Well, if we look down here in terms of our properties here, when we look in the mirror, we see ourselves. We see a reflection, which means that the reflexive property is also going to be an option here. And we can cross that out. And already we have more than half of the proof filled in. And once we get half of the proof filled in, then we should be able to get at least 1 point when we're taking the state test on this one. We know that step 4 is really going to be either the first two at the bottom of the box, the side, 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 or the side, angle, side. We'll be touching on angle, side, angle, and angle, angle, side in our next set of notes. But we have two choices there for 4. And now that we have these reasons in here, let's go back and fill in the rest. And I got taught a little bit of a trick here about identifying the alternate interior angles. And what someone told me is draw a Z. So here's a parallel line. And here's the parallel line. And draw the Z in there. And if we draw the Z, the angles that we're working with are, I'm going to switch colors, here and here. So then once we identify those angles, then we can fill in our statement. And that is angle RQ, can't see it now, S is congruent to angle TSQ. Again, I colored in my letters, but I'm correct. And we did really kind of color over it, but this side and this side were given to us as they were given. So those are congruent already. So when we label these, again, order really important. Since I did RQS, I had to go in the same order. I had to go TSQ because we started with the one tick mark part of that. And again, now we have even more than part of the proof filled in. But the next part then is going to be the reflexive property. That's the shared side. So if we can recognize that we're working with shared sides, we can put those marks on there, and we can say that QS is congruent to QS. And I forgot to look at my word banks down here, but we'll go and check and make sure. And I definitely see the QS is congruent to the QS. Do we see the angle RSQ, RQS, and TSQ? RQS, TSQ. We can get rid of that one. So we've got that option as well. And we have our picture pretty well marked up. But hopefully we can see, and again, highlighter still might be helpful, especially for that Z idea of the alternate interior angles. But as we finish this one, what we see is we've got a 1 tick mark, we've got an included angle, and then we've got a 2 tick marks. In the triangle that's kind of to the left. Same thing over here on the right. We've got a 2 tick marks, sorry, a 1 tick mark, an included angle, and a 2 tick marks. And ask ourselves, do we have 3 sides, or do we have 2 sides and an included angle? And we ended up to have side, angle, side.